My name is Sebo, and in this video, I will present the work that I've done in collaboration with Ling, Chang, and Scassellati at Yale University. Our work is titled Strategies for the Inclusion of Human Members Within Human-Robot Teams. Now to begin, inclusion is an incredibly important component of collaborative teaming. When studying human teams, work has found that the perceived inclusion of human team members, how included a person feels within a group, is positively correlated with both their commitment as well as the team's overall performance. As robots increasingly join collaborative teams of people, it is important for us to consider how robots may influence people's perceived inclusion within human-robot groups. So in this work, we investigated two strategies that a robot could use to hopefully increase the inclusion of human team members. The first strategy we examined is being given a specialized role to interact with the robot. This specialized role emulates much of what we see today when a robot is incorporated into a human team, where one human team member is designated as the robot operator or controller. The second strategy that we explored is supportive utterances from the robot. We investigated these two strategies in a human subject experiment that involved participants completing 2 rounds of a collaborative task. In the first round, 2 people and 1 Sebo robot interact together for 15 minutes. At the same time, a third participant and another Sebo robot interact together for the same 15 minutes. We did this in order to create an in-group and out-group. Then we brought the out-group member to join the room with the 2 participants and that Sebo robot for a second round of the task lasting 30 minutes. This 2-round design allowed us to create an in-group and out-group in the first round and to test our strategies for inclusion in the second round. So in order to test our first strategy of improving human team member inclusion, we designated one of the participants as the robot liaison at the beginning of the second round. The role of the robot liaison was to gather information by asking questions to the robot related to the task. In our first between subjects condition, we designated an in-group member as the robot liaison. And in our second between subjects condition, we designated the out-group member as the robot liaison. In order to test our second strategy of improving human team member inclusion, supportive utterances from the robot, we had the robot say utterances such as, "Good idea, Sarah," to participants during round 2 of the task. These supportive utterances were directed at all 3 human participants. For this human subject study, we recruited and ran 13 groups in each experimental condition. I'll now describe our hypotheses related to these 2 strategies to improve human team member inclusion in the context of this experimental design. Our first hypothesis is that robot liaisons will positively influence inclusion. We thought that the robot liaison's role to provide the group with task-relevant information would be a valuable contribution to the group, increasing that team member's feelings of inclusion. Additionally, we thought that the supportive utterances from the robot would positively influence inclusion. We thought that both the robot liaison role and supportive utterances from the robot would be especially helpful for the inclusion of the out-group team member. The task that we had participants complete was a modified version of the desert survival problem. In the first round, participants were given a list of 25 common household items and were asked to rank them with respect to how useful they thought they were for survival. This task was completed both by the 2 in-group members as well as the out-group member in their separate rooms. In the second round of the task, when all 3 participants were together, the participants were given information about the environment where they were to be stranded. And then, as a group of 3, they were asked to produce one final ranked list of 8 survival items. We introduced information about the environment in round 2 of the task in order to provide participants with additional material for further discussion and to encourage questioning of prior assumptions. The robot liaison's role was to gather information about the survival items and the environment. They did this by verbally querying the robot. Here are some examples. "Hey Sebo, tell me about the chocolate." "Hey Sebo, tell me about the season." Next, I'll show a video example where a robot liaison in the experiment asked Sebo about the weather.
"Hey Sebo, tell me about the weather."
Weather. Life-threatening temperature is rare, but does occur. Make sure you save up supplies to survive a 3-day-long blizzard. There's also lots of heavy rain.
The robot also delivered targeted supportive utterances during the task. Here are some examples. Let's say Melissa says, "I think we need a coffee pot." The robot might rephrase her comment to say, "We need a coffee pot, good idea, Melissa." If Robert were to say, "A camera could reflect light," the robot might pick up on the mention of camera in Robert's utterance and respond with, "Camera, Robert, I think that's worth considering." Lastly, let's say Jennifer said, "Rabbits are good, you can eat them." The robot could respond with a general statement of, "Okay, Jennifer." Each participant received approximately 6 of these targeted supportive utterances over the 30 minutes of the second part of the task. I'll now share some video examples of the robot's targeted supportive utterances during the experiment.
Because they said there's
newspaper for fire.
Newspaper. Oh, where should that be?
Just put it in 6.
Newspaper. Good idea.
from where we are, it's 15 miles away, but we can get closer.
Yeah, we can just.
Yeah.
I mean, I assume that we know where the street is.
Get closer. Good idea.
We used the following measures in this experiment: the talking time of each participant, the initial survival item rankings compared with the final survival item ranking, participant psychological safety, participants' perceptions of group cohesion, participants' perceived inclusion, and participants' perception of the robot according to the Rosas scale. Now for our results. We found that the perceived inclusion of the robot liaisons was significantly less than other group members. These findings have important implications for the increasingly prevalent number of human-robot teams today, as robot members are frequently incorporated with a human liaison, such as factory robot operators, robot controllers in search and rescue, and surgeons controlling robots in surgical procedures. These results indicate that having someone with a robot liaison role in a human-robot team may actually be detrimental to the perceived inclusion of those liaisons. Our next result examined the survival item selections by in-group and out-group members. At the end of round 1, the 2 in-group members produced one ranked list of 25 survival items, and the out-group member also produced one ranked list of the 25 survival items. And then when they came together for part 2 of the experiment, they produced one final list of 8 items. From these ranked lists of survival items, we examined the items that were initially ranked low on the in-group list and high on the out-group list, and looked at how many of these items made it onto the final list of 8. For example, let's say that the in-group members rated chocolate low on their initial list. However, the out-group member thought that chocolate was extremely necessary and ranked it high on their initial list. What was the likelihood that chocolate would end up on the final list? We found that when an in-group member was the robot liaison, 47% of the items ranked low by the in-group and high by the out-group ended up on the final list of 8. However, if an out-group member was the robot liaison, only 32% of these items made it onto the final list of 8. This difference was statistically significant. This result highlights the dangers of having an already excluded team member take on a specialized role, as the outgroup participants had less of their ideas incorporated into the team's final decision when they were given a specialized role to interact with the robot. Finally, we examined the impact of the robot's targeted supportive utterances. We did this by looking at the amount of time participants spent talking in the 1 minute after the robot delivered a targeted supportive utterance to them, compared with 2 controls. We wanted to see if the targeted supportive utterances had an immediate effect on the verbal contributions of the participant being supported by the robot. First, we examined the amount of time that a person spent talking after the robot supported them with an utterance such as, "Good idea, Sarah," and compared that with the time a participant spent talking after the robot supported someone else, such as, "Good idea, Tom." We did this by subtracting one from the other. We found that out-group members, more than in-group members, had a significantly positive change in the amount that they talked after the robot supported them as opposed to someone else. We also examined the amount of time that a person spent talking after the robot supported them with a second control, the time a person spent talking after an undirected utterance from the robot, such as, "Okay." We found the same result as before, where out-group members, compared with in-group members, talk more after the robot specifically supports them, as opposed to when the robot made undirected utterances. These results provide evidence that out-group members talked more after robot-targeted support. Thus, it seems likely that targeted supportive utterances are helpful in encouraging and including participation from excluded team members. To conclude, we examined these 2 strategies to improve the inclusion of human members within human-robot teams. The first, being given a specialized role to interact with the robot. And 2, supportive utterances from the robot. The results from our human subject experiment indicate that a specialized role to interact with the robot has a negative impact on perceived inclusion, and especially the adoption of ideas from out-group team members. In contrast, the supportive utterances from the robot in our experiment had a positive impact on the verbal contribution of out-group members, providing evidence in favor of using robot verbal support to include the opinions and ideas of marginalized team members. We hope you enjoyed watching this video, and we encourage you to read our paper and watch our supplementary video to learn more about this work. Thank you.